First, I want to start by saying that I'm very honored to be in front of you guys today. And secondly, I want to give you a bit of intro about myself. I'm from Iași, one of Romania's biggest and most beautiful cities, famous for its warm people, delicious food, beautiful scenery, and last but not least, a highly skilled IT industry that I'm proud to be a product of. Furthermore, I have over 11 years of experience in software testing, and throughout this time, I've held several jobs, but what I personally believe that entitles me to stand in front of you guys today is my experience in the automated field. So 7 years ago, I started working for a company that's called Smart2Pay, which is a Dutch-based payment service provider, which at that point, 7 years ago, had as a main product an API that provided merchants from all around the world with access to integrating alternative payment methods. What are alternative payment methods? Well, these are some of the ones that we currently integrate. PayPal would be the most famous example. Basically, our products come to the rescue whenever merchants want to integrate several of these payment options, and instead of having to sign one contract and integrate one API for each and every one of these payment options, they just come to us, sign only one contract, integrate one API, and by that, they have access to over 200 payment options from all around the world, from Brazil to Japan, and everything in between. And this photo, this picture, I personally like to call Smart2Pay master plan for world domination. They're basically the countries in which we offer integrations for. But coming back to me, where do I fit in this master plan of world domination? Coincidentally, the countries are also purple. Well, yours truly is the main responsible for building the company's end-to-end automated tests framework, which I built from scratch by myself. And again, the first version of it was built in Autoit using Selenium Server. Later on, I've moved my code to C# using Selenium Webdriver and Nunit. The code for the test applications is completely independent of the application code. The tests run as standalone applications on a machine in a virtual cloud, and they run daily, triggered by scheduled tasks, and send emails with their results and reports to both me and the important stakeholders for the project that are being tested. I started working on it 6 years ago, and I'm still working on it right now. And throughout this time, I like to believe that I've gathered quite a few stories, which I want to share with you guys today, because I personally consider them to be valuable when and if you decide to design your own automated tests framework, or probably even decide whether or not a commercial one best suits your needs. And the first aspect that we have to take into account as, again, software testers, when designing tests, is code. Basically, when it comes to code, you have to think before you write it. And that's easier said than done. Because in my case, 7 years ago, there was darkness. And my boss comes to me one day, and he's like, "Hey, Mada," because again, you can call me Mada. "Hey, Mada, let's start writing some automated tests. And let's do it for the 80+ payment methods that we currently integrate. Let's run those tests both on production and on the test environment on Chrome, Firefox, and IE." Back then, we had, again, Autoit, which I don't know how many of you are familiar with, but it's basically a tool for designing automated tests for desktop applications. So we had Autoit and Selenium Server, so let's write some tests, right? But again, Mada from 7 years ago. Let's see how the manual testers are doing it. Basically, the manual testers would use this app, in-house app, such a strong word, which they would use so as to send the payment details for the 80 payment methods that they wanted to test, so as to send the payment details as a SOAP request to our main product's basic endpoint, which was a web service. So all this app did was just sending the SOAP request to the web service. And again, the testers would manually select the desired payment method from the drop-down down here. The payment details would magically show up here. They would click on this button right here. The web service would respond. The payment got sent to our system. The web service, again, would respond. The response contained the redirect URL, which they would load into a browser and carry on with the payment flow through our application in the browser. And the way I've written my tests back then, they did exactly the same thing. Open this app, select the payment method from the selector down there, click on the invoke button, and I did it like for the 80 payment methods that I had to test. And those tests would run each night on both production and test environment, Chrome, Firefox, and IE. So unless the purpose of your tests is to test desktop applications, don't do it. And most definitely don't let them run unattended. If you do it, don't let them run unattended at night. Because again, my tests would run each night on all those configurations that I previously mentioned. So it was just a matter of time until something went wrong. And I was well in my first year at the company. One day I got to work, one morning actually, I got to work, just to find my colleagues from the support department and also the product team freaking out because during the previous night, an abnormal number of payments magically appeared on the production database for a payment method that hadn't had activity on the production environment in a while. So again, payments in our system have to be initiated by merchants that have to sign contracts and go through a whole process. But those payments, nobody could account for. So yeah, meanwhile, Mother, like in her corner, like having her coffee, like, I wouldn't want to be you right now. But basically, after a whole day of painfully searching the logs, they figured out that the calls were coming from inside the house. They had all those payments had all been initiated by my tests, because throughout the night, those scripts that were supposed to iterate through all the selector in the options, for all the options in the selector down here, failed to do that. But they did not, however, fail to click on the invoke button, thus inserting those payments, sending the payments to the system. And I ended up having 240, because 80 payment methods multiplied by 3, 240, bam, payments on the production environment, and people that had better things to do than to search for my ghost payment in the log had wasted basically a whole day. And the lessons that I've learned. Basically, automated tests are not just manual tests performed automatically. If I wasn't so keen so as to automate the whole app, that's weird app, so as to send the SOAP request to the web service, I would have done the normal and sane thing to do, which would have been to send the SOAP request from within my code in just 5 lines of code. So if we have the power and knowledge to write code, then let's do it smart, right? So, because the company is not called Smart to pay for nothing. Yeah, so, and again, whenever testing on production, you should choose to cover your tracks wisely. Either delete the data that your tests have added to the production, and if you cannot do that, at least mark that data so as being part of a test, because you might end up making somebody's life, that person that has to monitor those production environments, the production database or whatever, you might make life much easier for that person. And last but not least, never underestimate the power of an automated script. Writing code for test applications is most definitely not an excuse for writing bad or redundant code. So please keep this in mind. Moving on. Infrastructure. Yeah, we are not allowed to use curse words. But infrastructure might stand in the way of your success, in the way of your awesomeness as an automated test engineer, but you have to deal with it. And my first encounter with infrastructure was when I had to deal with VPN connection. Because those tests that I mentioned previously, when that were running each night, they were running on a machine in our local network. And besides initiating payments, so as to check for those integrations, they would also check whether or not those payments got correctly inserted into the database. And in order to have access to the database from that machine that the tests were running on, I had to have a VPN connection up and running so as to access it. Needless to say, and my tests back then, they lasted from 8 up to 12 hours. IE was really slow back in those days. But again, 8 to 12 hours of tests. I found out the hard way that the VPN connection got automatically disconnected, security measure, after 8 hours. So all of the tests that would run from that point on would start failing because they could not perform their database checks. My colleagues that were manually connected to the VPN, they would use this app. Fill in their username, password, click on whatever. I thought about writing a script in Autoit, which would also automate the whole connection of like filling in this. But lessons learned from the previous stories, the previous experiences. So we have the power and knowledge of code, right? So I did just that. From within my code, each time that a test required access to the database, I would ping for the database's IP, right? Because that's the oldest trick in the book, ping for it. I would ping for that server's IP. If that ping would timeout, that obviously meant that the VPN got disconnected. And using a CLI that came in the program bundle with this app, I would reconnect the VPN so as to make sure that at least throughout the whole duration of that particular test, I would have access to the database. Needless to say that then when the next test would run, it would find the VPN connection up and running, everything smoothly. So VPN connection maintained, achievement unlocked. Next, browsers. What's the downside of having like your tests running automatically, being started by scheduled tasks on a machine that you don't have to log into? You don't get to see them crash. And it happened to me, and not only once, to have my tests failing because the tests from the previous night failed to finish properly or crashed, and they just left like dozens and dozens of browsers opened up there that would just impact the performance of the current running tests. Because having dozens and dozens of browsers obviously has an impact on your machine, on the CPU and RAM and all that stuff. So last week I had 2,000 browsers. Talk to me outside about that. That's a story. And the way I chose to deal with it was each day at a certain time that I know that there were no tests running, I would like trigger a script that would basically kill all the browsers, all the processes even remotely associated with the browsers. And by doing this, I made sure that each test that would run from that point on would have a clean machine on which it could run. Conclusions. When it comes to infrastructure, always, never assume that your prerequisites are in place when running your tests. Check whether or not they are, and if not, try to establish a coping mechanism. And again, like I did with my VPN connection. And if you cannot do that, at least try somehow to, not somehow, like really do it, mark those tests as being inconclusive rather than failed. That's a matter of transparency. And again, clean the mess you've left behind, whatever that mess might mean in your case. Again, kill browsers, processes, and whatever it is that you're failing tests, because we as testers have to be prepared for the worst case scenario, right? Clean everything that you're failing tests, like the code that fails, the code that you've written, might leave behind. And that's where things get interesting. I'm gonna have a sip of water. Just. I have a few stories about this, but they're too shameful to share. But then again, I have a friend who has a friend who did this on production. But what's the worst thing that can happen? You might get called into the CTO's office, and he might show you this query. So, but like, what do you do then? You just bow your head in shame. You go back to your desk and rewrite probably like 80%, off the top of my head, 80% of all the queries that you were running on the production database. And that's that, right? Lessons learned, moving on. Nope. And again, coming back to my story, because that was a totally hypothetical story that nobody ever experienced it, ever. Coming back to my story, at some point we've acquired a few merchants with thousands and thousands of users. And when I first started working for the company, we had the overall number of payments in our system was around a few hundred thousand payments. At one point, the production database grew up to surpass 100 million payments. So it basically grew up in size like thousands and thousands of times. We celebrated and had cake that day. So for a system that's that complex, with sales promoted throughout the internet and like Black Fridays and Cyber Mondays and stuff like that, it's not abnormal to have spikes on the CPU and I/O operations for the production database every now and then. And the New Relic, which we used back then to monitor our production systems, would raise a few flags that every now and then the usage went up to 100%. They would happen during the night, but nobody could quite actually put their finger on it. Up until one day, when a deploy on production was made. And again, the deployment was done, I had to run my tests. They were supposed to be lasting around an hour, because I recently discovered the magic of running my tests in parallel. I was supposed to add about 1,000 payments to our system. And so I decided running them in parallel. It was a test set that I would run each day, so nothing out of the usual. I decided to run them on my local machine, on my workstation, because it is rather more powerful than the virtual machine in the cloud. So I started my tests, and I went, because it was during lunchtime, I decided to go have lunch. And after 15 minutes, one of my colleagues calls me. They never call me. Madam, can you please come back to the office? Your tests are killing the production environment. For a system so as complex as ours, each second, we're not talking minutes, each second that the production is down costs us a lot of money. We have an SLA of 99.99%. I was skeptical about me ruining the production, killing the production, but then again, I went back to the office, because it's the office, right? That's where money for food come from. So I went back to the office, and this is an actual photo of my colleagues. Because they were like 10 people gathered around my workstation, because they knew that the tests were being run from that machine. And they were basically just trying to log on, or searching for processes that would have Selenium in it, because they know that I'm running Selenium tests. Basically, they were trying to do anything that could stop that evil machine from ruining their day. my first question was, why haven't they unplugged it? But then again, I stopped the tests, and the CPU usage for the production went back to normal, but I demanded answers. So I rushed into the CTO's office this time. Why are you blaming this on me? These tests have been running each day. I've run them after deploys dozens of times. Why is this happening right now? Well, basically, the answer that I've got was that I was checking for the payments being correctly inserted in the database by querying that table that had over 100 million entries. You remember the cake, right? 100 million entries. And I was performing my selects using columns that had no indexes on them. So the search mechanism, I'm no DBA expert, but the search mechanism would get triggered into the overall 100 million payments. And obviously got a lock on it. And my tests were running in parallel, so you get this 100% plateau. But still, I had run those tests the previous day also, and nothing like that ever happened. Nothing like that happened. Basically, that's where the lesson is that the lesson to be learned here stands. With each payment that was added to the production, not necessarily by me, but also by the merchants, my influence over the database grew even more and more threatening. Because my tests were scalable so as to accommodate tests for 80 payment methods and also for 300. Thousands of users, hundreds of users. And my code was scalable. But the access to the database from my code was not. So the conclusions. Whenever it comes to testing on production, think scalable. Consider your interaction with the production database as scalable. And if you do not have access to figures so as to how big the production database might be, try to refactor your queries as often as possible. Because a large number of small tolerable issues might add up in the end and cause a big crash. And last but not least, when in the CTO's office, stay humble because he is not the CTO for nothing. Moving on. Reports. In my book, reports have to be useful rather than pretty. And when I started running my tests using Nunit, I noticed that Nunit generates at the end of the whole test set an XML report. And again, we don't have to reinvent the wheel. So I searched for tools that would parse this XML report, which you can configure any way you want, again. I searched for tools that would parse this and convert it into logs that my colleagues could use. And also send emails, because my tests have to send emails. But all I could find back then were tools that provided me with beautiful pie charts and graphs, and I have nothing against pie charts. But my colleagues, the ones that were reading my logs and receiving my emails, they had to have access to clearly structured data. What tests were failing? Why were they failing? How many failed, how many passed? But still, information that they could use so as to search for my payments, the test payments in the application's logs, or, I don't know, debugging and stuff like that. So not finding what I actually needed, I decided to write my own library, which, because it parses NUnit results, is obviously called parse NUnit results.dll. And this is a screenshot from one of my emails, the emails that it sends. The only color here is the red that states that this test has failed. But then again, it clearly states the reason for failure and so on and so forth. So when it comes to reports, your reports, the test reports, have to be relevant for the people reading them. If your reports get sent to the manager, give them pie charts. If your reports get sent to technical people, give them the technical information that they need. Flakiness. My tests have a certain degree of flakiness that's added, let's say, by the huge amount of configurations in our system, and also by the fact that I also have to test the third parties, the payment provider integrations. So in order to provide my colleagues with the reliable results in my reports, I had to answer these 4 questions. And those were my answers, which I implemented into a mechanism that monitors all the test sets that run throughout a whole day, and which basically, again, monitors what tests have failed. It rechecks them so as to make sure that it wasn't a one-time thing. It counts the number of successive failures for a particular test. And based upon that number of successive failures, it suggests, let's say, an action, whether to escalate that problem, the problem that the failing test has revealed, as to be fixed. And if nobody fixes it, then that test obviously does not need to be run again, up to a point. So this is, again, a screenshot. I'm into screenshots. This is a screenshot from the log of that monitoring mechanism. And on the top, it's the name of the test set. On the bottom, we have 1 fails. These test cases have failed only once, today, let's say, because it's per day. But on the top there, those tests have failed for a number of times, consecutive days, consecutive fails, that can be evenly divided by 20. I don't even know how many, like, what's that number? It might be 20, it might be 200, it might be 2,000. And that, in my book, this is a test that must get the attention of the people monitoring those tests, and that is the test that needs to be skipped, because it does not provide any new data to the test reports. And last but not least, when it comes to reports, reports have to be available as soon as possible. So again, as an advice, my life changed. Again, a screenshot. My life changed when I discovered the magic of running my tests in parallel. As you can see, it takes my CPU percentage out of 100, up to 100%, but then again, it opens 30 browsers. So in this way, I managed to reduce the duration of my post-deploy tests from 6 hours, up to 20 minutes, let's say. So try to find a way, there are ways, of running your tests in parallel. It helps. In conclusion, when it comes to reports, they have to be relevant for the people reading them, pie charts, or technical data, reliable, deal with flakiness, whatever that might mean to your project, clean. If there are issues that your tests identify, like failures in your system, that your tests highlight every single day, skip those tests, or ask whether or not you can skip those tests from the sets that run daily, or with a certain degree of repetitiveness. Because those tests do not bring any new data. They don't add value to your reports. And people monitoring those reports might get lost into all the known issues and miss the issues that need to be observed. And again, ASAP. Team. Basically, us as test automation engineers, engineers in test, automated test engineers, or whatever you want to call yourselves these days, I personally believe that we should not keep all that automated awesomeness to ourselves. And the story that comes to mind was when we integrated a payment method from South America. And the problem with that integration was the fact that it had to be available in, I believe, 10 countries, several different countries in South America. And that provider required for each payment, even the test ones, required a unique and valid social security number, with like stressing the uniqueness of it, and also for its test payments. So I had to write some tests, right? So again, I searched for the algorithms validating the social security numbers in Argentina, in Chile, and so on and so forth. Then a random number generator, bam. For each test, I would have a unique and valid social security number for each payment, depending on the country. Like, at some point, I had a coffee with one of my colleagues, and I found out that all the people that were working on that integration, testers, developers, product owners, because again, they would have to work on it, so they would have to perform test payments. And each and every one of those people, they had like 10 different websites opened, searching for social security numbers, and if they could find one, it also had to be unique. And I was like, dude, I have the code for this already written. So I designed this small app, which is a Windows Forms app, that calls my library that generates the social security number. And needless to say that everybody started using it. They are still using it right now, years after. And I'm not necessarily saying that I saved the day with my small app of generating social security numbers. But then again, sharing is caring. And it's not necessarily caring for your teammates, but for the overall quality of the project and of the product. And if we deliver awesome products, one day, everybody gets a piece of cake, right? So hopefully I haven't made you hungry up until this point with all the cake photos. But just to conclude, when it comes to your team, try to help others. Ask for help. I have dozens of stories of when I needed help on writing my framework. And basically, the DevOps and the systems administrators and the developers are your best friends. So ask for help. And last but not least, join a community of your peers. Because in my opinion, being active in a community, it provides us with access to an infinite number of experiences paired with an infinite number of skills by people who are willing to share both of them. A bit of what we're doing right here, right now. So I'm going to leave you to this. I want to say thank you. These are my main takeaways. And hopefully, you will find them useful, again, when you decide to write your own automated test framework. Thank you.